Alright, I'm gonna start filming now. It's gonna be terrible. Alright, so I have from here. Yes, I'm using this background. Also, the speed of light is kind of a misnomer. We know that the speed of light is the fastest anything can. Nope, almost. Also, the speed of light is that. Got it right the first time. Also, the speed of light is kind of a misnomer. We know that the speed of light is the fastest anything can go, right? Well, light is just the only thing that can reach that speed, so it's better to be named the universal speed limit instead. Also, the speed of light is kind of a misnomer. We know that 300 million meters per second. Also, the speed of light is just the fastest. No, that's not how it starts. Also, the speed of light is kind of a misnomer. We know that 300 million meters per second is the fastest anything can go, right? Well, it's just light that is the only thing that can reach that speed, so it's better be called the universal speed limit instead. So, we know E equals mc squared is incomplete, where E is energy and m is mass and c is the speed of light in a vacuum. But wait a second. If we increase energy, which would happen when we increase speed, wouldn't that also increase mass? That means as things approach the speed of light, they're increasing in energy and also increasing in mass. If they're increasing in mass, then it increases in the energy it has to take to move them, which means they just have to go faster and get heavier still. Okay. If increasing speed increases mass, then it explains why only light can go the speed of light. It acts as both as a wave and a particle, which explains why it can... no, almost. If increasing speed increases mass, then it explains why only light can go the universal speed limit. Light photons act as both particles and waves, so it explains why they have no mass and can still carry energy. I'm just doing the ones that have my initial in front of them. To answer the question, is the person running faster than light, we look at the proven example. No. To answer the question, is the person running faster than light, we look at a proven example. Muons are particles that form high up in the atmosphere. Nah, I don't know what a muon is. Shit. Okay. This second page, it says to answer the question, like right at the top, or it has explain in parentheses. You have to explain what a muon is. I don't know. Screw it, I'm just going to read it without... I'm not going to look it up until later. To answer the question, is the person running faster than light, look at a proven example. Muons are particles that form high up in the atmosphere. When the particles form, they travel at almost the speed of light, generally downward. Muons have an incredibly short half-life and mathematically should be depleted by the time it reaches the surface. But instead, there's a noticeable amount of muons when they reach the surface, which means that time was shifted during the muon's descent. By this method, the realism of time travel, we can see that it's impossible to travel back in time. By this method, the realism of time travel, we can see that it's impossible to travel back in time. But that isn't entirely true. It's a very real fact that scientists have known for a while. Light, for our massive universe, is actually pretty slow. It takes eons for light from faraway places to reach Earth, and most of the universe is too far away, and light hasn't even reached our planet yet. It takes eons for light from far away to reach places. It takes eons from light from far away places to reach Earth, and most of the universe is too far away for the light to have even reached us yet. That's why the sky is black. Yeah, that's why the sky is black between the stars, not because there's nothing there, but but that because the light hasn't reached us yet. That's why there's That's why the sky is black between the stars, not because there's nothing there, but because the light hasn't reached us yet.